Okay, for this question, show that if z is equal to e to the I theta and z is not equal to -1, then z minus 1 over z plus 1 is equal to I tan of half theta. Now, before we do a question like this, I'd like to remind you about a few things about complex numbers here. First of all, if z to the power of z is to the power of n, we're going to get e to the I n theta, which is also basically cos n theta plus I sine n theta. And also 1 over z power n is equal to e to the minus I n theta, and that is equal to cos n theta plus I sine n theta to the minus 1, which is equal to then cos n theta, okay, minus I sine n theta. Very important. And let us recognize this now. I've got z minus 1 over z plus 1. This can be rewritten as z to the half, okay, minus z to the negative half divided by z to the half plus z to the negative half. Now, why is that? Basically because if you take z to the half minus 1 over z to the half, which is this one, divided by z to the half plus 1 over z to the half, then you're going to end up with z to the half times z to the half, which is z, okay, minus 1 divided by z to the half, and then divided by here z to the 1 plus 1 divided by z to the half, which basically boils down to z minus 1 over z to the half times z to the half over z plus 1, and this cancels out, and I'm left with z minus 1 over z plus 1. I just wanted you to know that this can be rewritten as that. This is the proof, okay? So where do we go from here? Now, if you take z to the half minus z to the negative half, which is this, what is basically z to the n over, z to the n plus 1 over z to the n? I'm going to say cos n theta plus I sine n theta, okay, plus cos n theta minus I sine n theta. And if you do that, this and this sign is going to cancel it out, and I'm left with 2 cos n theta. Similarly, if I have to do z to the n minus 1 over z to the n, it's going to be equal to cos n theta plus I sine theta, sine n theta okay, plus cos n theta minus I sine n theta. And okay, there's a minus here, that should be the minus, pardon me. So the cos and cos disappears, and I'm left with 2I sine theta. So the n is the power half here, and it's also the angle, all right, because n theta everywhere. Therefore, for z minus 1 over z plus 1, which is all of that, you're going to get the numerator, in the numerator, z to the half minus z to the negative half, which is this one, is 2I sine theta. So 2I sine theta. And then divided by z plus 1, which is z to the half plus z to the minus half, and this is it, the z to the half plus 1 over z, this are the same, is 2 cos n theta. So 2 cos n theta. When I say n theta, I mean theta divided by 2. So why? Because this can be written as this. So the element of half mustn't be forgotten here. So I'm left with this, cancels out, and it's I sine of half theta divided by cos of half theta. We all know that sine of a cos is tan. So I, tan of half theta, and that has been shown because we were told to prove that it's going to be equal to I tan of half theta, and here we are I tan of half theta. Okay, take care. Hope that helped.